Here we're going to change up the notation a little bit, but it means the same thing. Arcsine is your inverse function for sine. Arcsine of the square root of 2 over 2. Remember that the square root of 2 over 2, you're putting in a ratio into the inverse function, and you're going to get out an angle. And the angles that we're getting out are angles in radians, because that's what's most common. So I'm going to draw my partial unit circle, and that's going to tell me the angles. So my angles can go from negative pi over 2 to pi over 2. So I ask myself, what angle gives me a ratio of square root of 2 over 2 for the sine function? Well, that's going to be a positive y value, because sine is your y value. And that happens at this angle right here, pi over 4. Square root of 2 over 2, square root of 2 over 2 happens to be both the x and the y value. Therefore, our angle is pi over 4. So what I think would be very helpful is if you were showing, let me show you this right here. If you were showing this work right here, that would be very, very helpful for you in your understanding. Okay, let's look at arc cosine of negative square root of 3 over 2. I'm going to start by drawing my partial unit circle for arc cosine. That's a half circle that starts at 0, and it goes around to pi. And we're looking for a negative ratio. Well, cosine gives me positive ratios in quadrant 1 and negative ratios in quadrant 2. So we're looking at quadrant 2 where we'll get those negative ratios. So I need my ratio to be negative square root of 3 over 2. And cosine is your x value. So what angle has an x value of negative square root of 3 over 2? Well, that's a pi over 6 angle. In quadrant 2, the pi over 6 angle is going to be 5 pi over 6. You're going to go this way right here, 5 pi over 6. So hopefully this is making a little bit more sense for you. Arcsine of negative 1/2. Arcsine of negative 1/2. This one you're going to want to pay very close attention to. My half circle, negative pi over 2 to pi over 2. Negative ratios for my sine function will not happen in quadrant 1. It's going to happen in quadrant 4. So I say, what angle gives me a ratio of negative 1/2 for y? Well, I'm going to fill in the x value, and I say that's a pi over 6 angle. Now the pi over 6 angle that occurs in quadrant 4 that is going to occur on that half circle is a negative angle. So this is a negative angle. We can't go outside the half circle to get to that terminal side. We have to take the route that follows along with that half circle. So negative pi over 6 is our answer. Now if you look at your flashcard for arcsine and the range goes from negative pi over 2 to pi over 2. That means that your angle, negative pi over 6, has to be greater than or equal to negative pi over 2, but less than or equal to positive pi over 2. So the angle that you say is the answer has to be between those two values. Has to be between those two values. Okay, we're going to do one more here, arctangent of negative square root of 3. If you want to try and give this one a shot, I would do that. At least maybe get started, draw your half circle, then you can press play and come back and check out your work compared to my work. Okay, our half circle is going to go from negative pi over 2 with an open circle to positive pi over 2 with an open circle. There we go. And negative ratios for tangent will occur not in quadrant 1 but quadrant 4. And I'm looking for y over x to be square root of 3, or negative square root of 3. So that means my negative square root of 3 over 2 is the y value. Positive 1/2 is my x value. That's a pi over 3 angle. And the pi over 3 angle is going to be closer to the y-axis, so it's going to be right there. And that angle is negative pi over 3. So if you got negative pi over 3, give yourself a huge pat on the back, because that means that you really, really got it. If you didn't get negative pi over 3, I just encourage you to go through the practice problems, and with more practice and drawing these half circles, you'll start to really memorize and learn the relationships between the ordered pairs and the angles, and then of course the quadrants.